Hi, welcome. So in this video, we are wrapping up our conversation about planes, and I'm going to do two examples dealing with planes. The first one is just finding an equation, and then the second one, we're going to be given 3 points, and we need to find an equation for the plane. So I guess they're both finding equations of planes. The first one's just set up a little better for you. So in this first example, I want us to find both the vector and the scalar equations just to get used to them. And this is going to be for the plane, and I'll give you a point and a vector. So it's the plane containing the point. Let's say the point is -2, 1, 3, and I'm going to give you the normal vector. So let's say it has the normal vector. We'll call it n is equal to 1, 1, -4. Okay, so we have a point and we have a normal vector. So in order to come up with the equations for this plane, we first need a vector that's in the plane. So we're going to use this point to help us come up with that. You can actually jump ahead to the scalar equation if you want, since we already have the x0, y0, and z0 here. But I like to go through the sort of process of conceptually doing all the parts. So we're going to start with this v vector, and it's going to be the difference between this point, -2, 1, 3, and some arbitrary point x, y, and z. So that's sort of the reasoning here for what we're doing. So we're going to do the x value minus the x value of the point, so x minus a -2, then we have y minus 1, and z minus 3. So that's me just finding a vector between these 2 points. This is the point in the plane, and then an arbitrary other point in the plane. And this gives me a vector in the plane we're trying to find. Okay, and I'm just going to clean up this minus right away so we don't have to rewrite it. So I have x plus 2, y minus 1, and z minus 3. Okay, so along with this, we were already given the normal vector. So we were given 1, 1, -4. And so again, this is the normal vector, which is orthogonal to the plane. And so since we have a vector in the plane and a vector orthogonal to the plane, we can find their dot product and it should be equal to 0. So this is just I'm just repeating the sort of thought process we talked about in the last video when we came up with these formulas. So here I have my n times my v, and we really just have to set this up. So I'm going to do n, that's 1, 1, -4, and it gets dotted with v, which is x plus 2, y minus 1, z minus 3. And if we set this equal to 0, we now have my vector equation. So we've actually done the first part of the problem. This is the vector equation of the, wow, that's a weird shape. Let's try it again. This is the vector equation of the plane. All right, so let me just label that so we have it. We found the vector equation. Cool. So to find the scalar equation, that was the other part, we just need to actually compute this dot product. So we just need to do the operation and then maybe simplify it a little bit. So to do the dot product, I multiply the x components, the y components, and the z components, and then I add them all together. So I have 1 times x, 1 times x plus 2, so that's my first x component and my other x component multiplied together. Then I add it to 1 times y minus 1. Those are my y components. And then I add it to -4 times my z component. And this is equal to 0. So I'm just computing the dot product and I know it's equal to 0. And I could actually just kind of write this as it is. So this is x plus 2 plus y minus 1 minus 4 times z minus 3. And this here would be my scalar equation. It's not very pretty looking, but it is a scalar equation, and we technically are done at this point. I'm going to do a little more work because I want to simplify this. There's some more simplifying we can do, but I just want to make it clear to you that this really is the scalar equation now that we have evaluated the dot product. And so we could be done here if we were trying to enter this into the homework system or something. However, we can simplify this, so I'm going to. And I'm going to suggest that you get in the practice of simplifying it because we can combine some terms together and it's just going to be a lot nicer when we do that. So I have x plus 2, and then I add that to y minus 1, and then I'm going to distribute that 4. So I have minus 4z plus 12, and that's equal to 0. Then I'm going to combine like terms. So I leave my x plus y minus 4z alone, and I'm going to put the other things together. So 2 minus 1, that's 2 minus 1, that's a 1. And then I'm going to add 12, so 1 plus 12 is a positive 13. And so here, this x plus y minus 4z plus 13 would be like my simplified scalar equation. And I think this one's just a lot nicer to look at, and it really didn't take that much work to get there. Okay, there we go. So we found our equation of the plane given the point and the normal vector. All right, so there are lots of things we could do with planes, and there are going to be some other types of problems we do. I'm just going to show you one of them because I think this one's a good one to know, and it uses some other things we've learned before. So for this last example, let's find the scalar equation of the plane through 3 points. And we're going to just do the scalar equation this time. So whereas 2 points define a line, we could just have 2 points in a line, we actually need 3 points for a plane. So I'm going to give you 3 points, and then we're going to use these to come up with the equation. So my first point is 1, negative 7, 2. Then I'll have 3, 0, negative 1. And I'll wrap up with 4, 1, 5. Okay, so we have 3 points and we need an equation of a plane. So normally when we need a plane equation, we need a point and a normal vector. So that's what I think of when I am asked to make a plane. So I need a point and a normal vector. And so here I have 3 points, right? I already have my points, but I don't have any normal vectors yet. So that's going to be our task, is to find that normal vector. Okay, so how do we go about doing that? Let me show you a picture, show you a graph, and hopefully you'll start to see where we're going with this. So I'm just going to kind of just like sketch out these points. I'm not in any way going to put them where they're supposed to be, but I'm just going to imagine I have my 1 point, I have my 2nd point, and I have my 3rd point. And together these are making a plane. So in order to find a normal vector, what I'm going to do is I'm going to draw 2 vectors just starting from 1 point. You can pick whichever point you want. I'm just like choosing one of them. So we're going to make vectors coming out, and I'm going to give them names. We'll call this one the vector A, and this other one the vector B. So we now made these 2 vectors in the plane. And what we're going to do is find a normal vector based on these. So we could put a vector going up. It makes a right angle with these 2 vectors. And this is something we learned recently, so we can come up with a normal vector by taking the cross product. So the normal vector is the cross product. So part of the reason why we like the cross product is it gives us these normal or orthogonal vectors. And so here we go. This is specifically going to use the cross product of A and B. A and B being vectors I made. So it's probably good just to note for yourself that we can choose whichever vectors we want going between the points. So you can choose which vectors to make with the 3 points. So if you're feeling at all adventurous, you could pick 2 different points here. You could pick points in a different configuration, and do these vectors differently and see if you get the same final answer. So you should be able to pick, I chose like the light pink point as my center, as my starting, and I drew the 2 vectors out, but you could start with the blue one and go out from there, or, you can pick whichever one you start with. So it's kind of cool. You have some freedom and it'll all work out in the end to be the same for every option we could do. Okay, so I'm gonna just copy down my points that I'm using so that I have them for below, and then we're gonna go about coming up with these vectors and then taking their cross product. Okay, so these are my points. All right, and we're going to do the vector A and the vector B. So the vector A, it goes from 4, 1, 5 back to 1, negative 7, 2. So it's going to be 4 minus 1, 1 minus a negative 7, and 5 minus 2. So I'm just subtracting the components here. So these are the x components, y components, z components. And then I just have to simplify. So putting these together, I'm getting 3, 1 minus negative 7 is 8, and 5 minus 2 is 3. So 3, 8, 3 is that vector A. And I repeat this process for the B vector. So I just picked these labels of A and B, but it's what we're going to use. So the B vector goes from 3, 0, negative 1 to 1, negative 7, 2. So I do the difference in the x components, 3 minus 1, the difference in the y components, 0 minus a negative 7. And then I do the difference in the z components, negative 1 minus 2. So here I'm getting 2, 7, negative 3 as my B vector. Okay, so remember, we're trying to make the equation of a plane. To do that, we need a point and a normal vector. We weren't given a normal vector, so I'm trying to come up with one. And the way I'm coming up with one is by doing the cross product of these 2 vectors. So we're just doing our own manipulation in order to make this happen, and we're getting there. So we're going to do n is equal to A cross B, where n is our normal vector that we're looking for in order to help us with the plane. Okay, so we get to use a cross product to help us out here. This is a good review of some cross product things, so let's go ahead and try that out. So if I have my vector n, I'm doing A cross B. A is 3, 8, 3, and I'm crossing it with 2, 7, negative 3. So I'm going to use the shortcut version to do cross products with the IJK notation rather than with the determinants. So I'm going to get myself some more room here. And let's set that up. So if I have that 3, 8, 3, I'm going to color it one color. And then we'll use another color for my other vector. Alright, so I have my colors for my vectors now, and I'm just going to set up the IJK notation. So I write IJK, IJ. This is just like a faster way to do the determinant part of the dot product. And then I list out my first vector, 3, 8, 3, and then I repeat it, 3, 8. And now I do the second vector, 2, 7, negative 3, 2, 7. And I go down the diagonals and then back the other diagonals. So this might not be like the way you do this. This is just one of the ways I showed in my other video. And this is like always how I compute cross products. I just think it's way easier to do it this way than doing determinants. So we're going to follow down the first diagonal. We do I times 8 times negative 3. So 8 times negative 3i. And then we do 2 times 3j. And then 7 times 3k. Then we're going to subtract what happens when we go the other direction on the diagonals. So now I'm doing this backward way. So I subtract. We're going to do negative 3 times 3j minus 7 times 3i minus 2 times 8k. And now we just need to simplify this. So I have negative 24i, 6j, 21k. Then I do minus a negative 9, so it's a plus 9j, minus 21i, minus 16k. All right, we're making progress. Now I just need to combine like terms, and we're almost done with my dot product. So the i's together, I have negative 4 minus 21. That's minus a 45i. My j's together, I have 6 plus 9. That's 15j. And my k's together, I have 21 minus 16. That's plus a 5k. And I just like looking at my vectors in vector notation, so I'm going to write it in vector notation. So this is negative 45 for the x, 15 for the y, and 5 for the z. And there we go. So after all of that computation, we finally have a point and a normal vector that we can use to find the equation of a plane. So now we have a point, and we actually have 3 options for the point, since we were given 3 to begin with. And we have a normal vector. That's the vector that we just found. So we're going to substitute this into our formula. I'll write the formula here and then we'll fill it in. So this is the scalar equation of a plane formula. It looks like a times x minus x naught plus b times y minus y naught plus c times z minus z naught, and that's equal to 0. And here, that a, b, and c, I'll highlight those. Those are the normal vector values. So for us, that's the negative 45, 15, and 5. And then the x naught, y naught, z naught come from the point that we're picking. Let's see if I can get those highlighted. So these come from the point we are choosing, and we have 3 of those to choose from. So I'm going to use the point 3, 0, negative 1, but just to be super clear, any of the points will work. So you're going to get the same answer regardless of which point you pick, which is really cool, so you can try it out if you want, make sure you get the same answer. But I'm just going to pick this one. I just picked one. Okay, so let's assemble it, and we're going to get our final answer here. So I put in negative 45 for a, and then I do x minus 3. 3 is my x naught from my point. Then I do plus b, and b is 15 for my normal vector. And then I have y minus 0. 0 is my y naught. Then I add it to c, which is 5 for my normal vector. And then I do z minus negative 1. That's my negative 1 for my point. And this is equal to 0, so I just need to simplify this and get a final equation, and I'll be done. So just distributing some stuff, I have negative 45x plus 135. Then I have plus 15y minus 0 plus 5z. That minus minus is a plus, so I have plus 5, and that's equal to 0. All right, I'm going to combine some like terms. So my x, y, and z's stay as they are. I have negative 45x plus 15y plus 5z My 5s are looking a little bad here. I'll try to fix some of those. Okay, and then when I put my constants together, I have 135 minus 0 plus 5. I have plus 140. And this whole statement equal to 0 is my final answer for my equation of the plane through the points that we were given. There we go. Almost. Oh man. Okay, well this is the scalar equation that we were looking for. And that's it. Cool. So we did some examples here where we found the scalar equation given the point and the normal vector. And then this last example, we were given 3 points and that's it. And we were able to find a normal vector by using the cross product and come up with our scalar equation. So that is it for this video. Thank you so much for watching, and I will talk to you next week when we learn some new things.